Well done.
Are we going to stand here, or do you want to sit down?
Yeah, let's stand. So
let's stand.
Give Bob a hand first here. So I'm going to quiz him for about 15 minutes, but this is also, I would be especially, there's feedback in this room.
That was me breathing.
That was you breathing,
Yeah.
okay. I still haven't gotten error correction for analog yet. But I also would love to bring in comments or questions from the audience. And here's how we're going to do questions and comments. I'm particularly interested in the folks who were part of this revolution. If you have a question, so everybody just practice me, do this. So come on, everybody in the room, raise your hand. Good, I know you all do it. If you have something that you just absolutely need to toss into this conversation at that exact moment in time, do this. Put up 2 hands, we'll bring it to a screeching stop, and we'll get a microphone to you. Does that sound cool?
Cool.
So go back a slide. Let's see if they can do it. Yeah. Because the other aspect about Bob is he is a fearless prognosticator. And he prognosticates often, and has been teased terribly for some statements where people decide he wasn't quite right. There was that period in the 90s when you were kind of dissing wireless.
I was right about that.
We're coming to that. You're finishing my thoughts. As someone who prognosticates for a living, I count on people like Bob because I get some of my best ideas from listening to him. So I love starting with this very tantalizing slide. Looking ahead, what's the biggest surprise you think we're going to see in the next 3 to 5 years coming out of the telecom space?
Hard question. To me, the most exciting surprise, I think, is going to be Moocs. So most of us have gone to college.
Does everybody know what a MOOC is? Massively open online courses.
So education's about to be disrupted. Most of us in this room probably got educated along the way. And that whole thing is about to get, like iTunes into music and
You didn't do bad for a guy who, never made it to Stanford.
I took management of high technology at Stanford University.
I take it back.
Yeah.
That was the maraschino cherry. Anyway, but You're right. And Stanford is ground zero.
So the
for where
MOOCs are happening. And you all know what a MOOC is and are generally in favor? Or do you have serious questions about the loss of interpersonal contact between the teacher and the student? Do you have those kind of worries? So here's how I handle those. It goes back to the invention of another bad idea, the BOOC, the B-O-O-C, which is today spelled B-O-O-K. It was obviously a very bad idea because before BOOCs, we would sit around the campfire and we would hear the story directly from the storyteller. But now we have these damn BOOC things. So now, like you've read The Great Gatsby, but you've never met F. Scott Fitzgerald. That's a problem. So the MOOC is really a bad idea.
Okay. But
you weren't expecting
you're not
that
getting
kind of
off that
answer,
easy.
No.
You're not getting off that easy. I mean, at Stanford on MOOCs,
Stanford keeps coming up here.
Well, it's just up the road. Udacity launched, Coursera's launched. We got 2 big operations. It's going to revolutionize things. What do you see? Just 1 or 2 tantalizing specifics of how MOOCs change things with education.
Well, for one thing, education is not going to occur between the ages of 5 and 22 anymore. Education becomes a lifelong learning thing. So I'm taking 600X through edX. It's Introduction to Computer Science and Computer Programming. I'm learning Python from my own desk in Austin, Texas. My son is at his desk in San Francisco. We're both taking the course, not that there's anything competitive going on there. And I'm older than 22, and I'm learning Python. And I think there's going to, so there's elimination of this age discrimination. There's age discrimination going on at universities. I'd have a hell of a time getting admitted to the University of Texas, or Stanford, excuse me. Just mentioned Stanford.
Well, back in 2005, I was having lunch with a friend, and I told him, we were both approaching 50, and I said, I know the definition of middle age. I'm a professor at a university that would not admit me again as a student. And I own a house in Hillsborough that I could not afford to buy again if I had to buy it. So when the 2008 crash happened, I felt so much younger because at least then I could own my house.
I see.
But
So age and wealth. It costs a lot of money to go to Stanford. What, 50 grand a
$50,000 a
year?
year.
So with edX, or the other methods, the other kinds of Moocs, or they're only called Moocs for now. They'll be called something else as they evolve. But now anyone, anywhere in the world can take Stanford or MIT or Nexus courses anywhere. So MIT recently reported on the people who are currently taking 600X with me, and they believe that there was a person in that course from every country in the world. There was some debate about how many countries there were and whether they counted Texas or not. But there was somebody from every country in the world, some of whom had these really hard, they were taking MIT's freshman programming course from a hut in Bangladesh. So second is getting to the other 7. We're basically, like we solved bandwidth with the internet, we're now going to solve ignorance with the internet.
Well,
that was grandiose, wasn't it?
I absolutely think it is. Bob, you know, one of his many qualifications is he's got a law named after him. How many people know what Metcalfe's law is? Show of hands. And the laws, one never names a law after oneself. That would be unbelievably gauche. This was conferred or inflicted on Bob by George Gilder back in the mid-90s. And Metcalfe's law says the value of a network goes up as a function of the square of the number of participants. So that, you know, the more people you put together, it doesn't just become arithmetically better, it's non-linearly better. And I think Moocs are a wonderful instantiation of Metcalfe's law. And I agree with you. The change is this isn't about everybody listening to the professor. This is about pure interaction using the professor as an excuse.
The Moocs don't do that very well.
Yeah.
Yet.
Yes.
But that's a problem that the Moocs need to solve, is getting a scaling method of peer-to-peer instruction
Well,
going.
is Dave Liddell in the audience?
No.
He's not. Well, but Dave likes to say that whenever we have a new technology, we tend to pave the cow paths. We always do an old thing with the new technology, and then it takes us time to get around to doing the big innovations. Which, question for you, when did you realize that, you know, this thing you started with a memo on May 22nd was going to be a really big deal? How long before you realized?
Well,
I mean, other than finally getting your Harvard degree, which I realize is a big deal, but.
Well, there's 20 times.
20 times?
20 times, not just one time.
Okay.
So one of the times was, and Dave Boggs will remember this, we, for a while there, where are you, David? David Boggs. So we built the first 2 Ethernet controllers for the Altos, Michelson and Morley. And then there was a cubicle area, and then all of the Altos in that cubicle area were all connected. And each of the research scientists got to buy an Alto, and there was a little box. Did you want Ethernet or not? Ethernet was an option.
Let's run the mic over to David there, get him in case he has a comment. So keep going.
So Ethernet was an option for a short period of time. And so here's the first answer to your question. One day, somebody removed the terminator from the end of the coax for some reason. They're beautiful things, those little terminators. They feel good in your hand. And so somebody stole it, which meant that the cable was no longer functioning. And what happened was 10 people stood up, looking over the cubicles, wondering what had happened. And in that moment, we realized that Ethernet was no longer an option. And thereafter, that box was removed, and people got Ethernet every time. So that was the...
And I was thinking that, I mean, today, you know, there's communications, networking has become like oxygen. You know, if you lose it for a couple of seconds, you notice it's missing. You're starting to get a headache at 30 seconds, and you're unconscious in 2 minutes.
So I left my iPhone in the hotel this morning. Imagine how I feel now. Excuse me, I just need to hold on to something.
Dave, yeah, you can borrow my iPhone. I got to get a new one. Dave, did you have a comment after you?
No, No, he told the story correctly.
Okay. That may be a first.
That
Bob.
could be a
We're
first,
doing
yeah.
pretty good here. So we have about 2 minutes left. If there was somebody with a question, we'd take a question right down in front. So it also, the way we do questions is look where the person holding the mic is, and then the person in the room farthest from them, raise your hand. It's to give them an exercise. Tell us who you are, your question.
I'm Thierry Trebon from 01 Informatique in France. So in 1988, were you afraid of token ring?
Afraid of?
Were you afraid of token ring?
Yes, imagine this. Imagine for about 10 years, every day, your wife, your board of directors, all of your employees, every market analyst around would tell you that you were doomed. And that the IBM token ring, because IBM made standards, it was the dominant computer company, they foisted what I like to call SNA on us. And token ring was coming, had come, and was eventually, I mean, there were a few people enthusiastic about it, but basically IBM was going to kill it. And imagine living like that for 10 years, and then Ethernet beat token ring, so that has scarred me. So for example, I don't take advice very well, because for 10 years I ignored all this advice, and it worked out. So I'm hoping to recreate that. So yes, terrified because of the power of IBM and their dominance. What they underestimated was the power of an open standard, and I'm referring to the old IBM now. There's a new company called IBM, which is different. But in that old IBM, in its dark little heart, was not committed to open standards, and its products were not interoperable. 3Com Corporation shipped IBM Token Ring before IBM did, and we had trouble selling it because our version of the Token Ring didn't have SNA dust sprinkled all over it. So we had
we got a two-hander over here. Say who you are.
Hi, my name's Jeff Thompson, and Bob knows me from way back. Were you ever afraid of AT&T? I mean, AT&T had ISDN that was supposed to be their answer to data.
ISDN ran at 56 kilobits per second?
Yeah, that was fast.
56, that was kilobits per second here. Ethernet started at the M level.
That's faster than 300.
I refuse to answer that question.
I was real afraid of AT&T 40 years ago today, but that was only because of AT&T security.
By the way, there's a new AT&T, and it's headquartered in Dallas, Texas.
So, we got, yes, please.
Just for the record, your wife did not say you were doomed for 10 years?
And that was someone with deep inside knowledge on what his wife said. So, last question before we push on. Failure. I mean, I kidded you a little bit about your PhD, which is in the normal nature of things. And you've had an extraordinary arc of a career. You've crammed more careers into the last couple decades than most people cram into their entire lives. One of my favorites was you were publisher at InfoWorld, a magazine that for 5 years refused to let you be a columnist. Stuart Alsop, as I remember, wouldn't let you be a columnist, and then you ended up as publisher. Talk about this. Stuart told me. Okay, well, maybe I'm wrong.
Robin, did Stuart? Oh, no.
Okay, so talk about that. We think of entrepreneurship as all about success, and yet we know most entrepreneurial ideas fail, most entrepreneurs fail, most Silicon Valley companies fail. You know, this is why, as we say, venture capitalists sleep like babies. They sleep for 2 hours, wake up and cry, sleep for 2 hours. And you've been a venture capitalist, so you've been on both sides of the risk of failure. What insights do you have for the rest of us about how do you deal with the prospect of failure? How do you make failure into success?
You don't fail on purpose. People say failure is really good and we do it a lot, but that doesn't mean you should do it on purpose. So failure is a frequent consequence of attempting something hard. And then I'll share the conventional wisdom, which is you need to fail fast. So when you, and this is a problem, once you start doing something, you become committed to it, and then when you, long after you should have abandoned it, you stick with it. So failing fast is an important thing. I'm not sure I was ever very good at that, and then failing fast.
Also, if you haven't, for those of you from outside the country, you know, this is the Bob Metcalf, I'm not real good at pool, but I like to play for money. Never been on this riverboat before, right? That you're not real good.
You suggesting that I'm hustling you?
No, I'm saying that you're very modest.
Modest, yes. Well, some people have so much to be modest about.
There you go again.
Yeah.
Good. Well, I think we're right at the end of the time. If there was...
No, we got 3 minutes and 30 seconds.
No, it's going the other way.
Oh, it is.
This is a software developer's clock that keeps counting past the deadline.
Oh, I see, yeah.
Good. So let's give a hand to Bob. He'll be back up in a bit. Good. And so now we're going to go into our first panel. Why don't you put the names up? I'll invite our first panelists up, Norm Abramson, Dave Boggs, and Bill Hawe, and Radia. Sorry, I'm going to get this right. I have another friend called Radia Perlman. Radia, I swear I will get this right eventually. Good. Come on up and grab a seat. So this panel, as we start here, this is meet the inventors of the Ethernet. And let's see, where can you put me down on this side and just shift everybody down one? Yeah, that's good. And the way we're going to do this, so we have, let's see, okay, got everyone. So, Radia, you're right next to me. Fabulous. We have 30 minutes. We have 40 minutes? 9:15. So, I'm going to shift this so I can see it from over there. Our time is short. You're going to learn more about each of these individuals in detail. We agreed in advance that the way I would introduce people is with haiku, rather than go down the lengthy careers and many distinguished accomplishments of them. So, Radia, 10 base T. Norm Abramson.
Wrong.
Spanning tree.
Spanning tree, sorry.
It has a T in it.
Sorry, spanning tree. Norm Abramson, ALOHA. Dave Boggs, co-inventor. Can we leave it at that, or? Yeah. Okay, he agrees. And Bill Hawe, Dick's Internet. So let's get started here. I want to start with you, Dave. Co-inventor, what exactly does that mean? Tell us what it was like to be co-inventor.
It was Bob's idea. I just helped him reduce it to practice, as they say. I was a grad student at Stanford, and every Friday afternoon, the master's candidates were required to attend a lecture from outside people, and they took attendance. Friday afternoon, mandatory lecture at 3 o'clock, and they took attendance. One time, Alan Kay gave a talk. He mostly talked about small talk, and that pretty much went right over my head. But at the end, he showed a bunch of pictures of 6-foot-tall equipment racks full of blowers and cards, and he said they were building a PDB-10 clone. So I was exploring doing a PhD research in high-performance CPU design, and that caught my attention. So I pestered Alan for a job at the Learning Research Group, and he looked at my resume, which is I'd worked at NBC as a broadcast engineer and built a lot of hardware. So he passed my resume on to another group that was doing a clone of Doug Engelbart's video terminal. What's the name of the Doug system? Anyway, the
NLS, Augment.
NLS, yes, right, at SRI. Because I had background in television, I ended up in that group fixing the televisions. The system was based on 15 Data General Nova computers that were all lashed together with the Data General Nova Data General proprietary network, time division multiple access system called the Multiprocessor Communications Adapter. So with that many computers, one of them was always broken, and I ended up being the keeper of the test stand machine where you'd swap parts out, and occasionally somebody from Data General would come out and use that to fix them. So one day, Bob had designed an Arpanet interface for the Xerox clone of a PDP-10, which was front-ended by Data General Nova. So his Arpanet interface plugged into the Data General Nova. And he built it, and it worked. Then they wanted to build another copy of the PDP-10 clone, and so they needed another Arpanet interface. Well, Bob's drawings weren't really quite up to date, and he wasn't really sure he could build the second one. So he had him wire it up with whatever he had, and then he needed a machine to debug it in. So he came to me because I had the test stand machine. So we spent a couple of weeks figuring out all the changes that he'd put into the first Arpanet interface that he never wrote down in the schematics. And then little did I know at the time, he was writing all those memos, inventing Ethernet. And so he started explaining it to me, and the pressure was growing on him to stop writing memos and start building hardware. So he'd been working with me. He knew he got along with me, I guess. So he turned to me and said, "Would you like to help me build this idea?" And he handed me a stack of memos, and that's how I heard about Ethernet.
Fabulous. Radia, you look like you're just about to ask a question.
No.
Good. Well, I have a question for you. So I know that there are some who we call Radia the mother of the internet, which here in California we all share in her wincing at because it is so politically incorrect to put. And I would actually invite the audience, we need a better phrase for this, because father of the internet sounds okay. Mother of the internet doesn't quite work. So we need a gender neutral name. This would be a good innovation for the industry to come up with. But leaving that aside, just how did the internet evolve?
Okay, well, actually,
Coming out of this.
I'll talk sort of about the spanning tree piece of Ethernet. But first, I'll say that, in keeping with this event, this protocol for asking questions, raising your hand, shouldn't it be like CSMACD that you just kind of...
Awesome. Okay.
Right, but at any rate...
Hand raising is over. Just barge in at any time.
Right.
And we'll do the error correction up here.
Right. Oh, and the other comment about CSMACD is that I seem to have it ingrained in me. I just sort of, that's the way I behave. I cannot interrupt somebody. And if somebody interrupts me, I just stop. But I'm always amused at meetings when there's other people that don't seem to understand CSMACD, and whenever they feel like talking, they just talk, even if someone else is talking, and they'll keep talking. You have 5 minutes. Anyway,
That's actually most software engineers I know.
Right. So back to spanning tree. So I was the layer 3 designer for DECnet, which meant that it's how you piece together a bunch of links and have the network self-forming and figure out how to move the data around with intelligent switches. That's another way to hook up a bunch of computers. So, and all the links were like point to point. It was only 2 computers. And then along came the Ethernet, and it was like, a new kind of link that I have to redesign the routing protocol to be efficient with this new kind of link. So I applaud the inventors of Ethernet. It's really cool technology, but they should have called it Etherlink and not Ethernet, because, it was all like bright and shiny, and everyone got all confused. And they thought it was instead of layer 3. And so they were building applications directly on Ethernet and leaving out layer 3. Ethernet was intended to be just a single link with, a limited number of computers and distance that you could do. So I tried to argue with them and say, hey, you still need layer 3. And they said,
How'd that work out?
Right. They said, oh, go away, Radia. You're just upset because no one needs your layer anymore. And I said, but you may want to talk from one Ethernet to another. And they said, our customers would never want to do that. So years later, my manager says, gee, we need to figure out a way, a magic box that will sit between two Ethernets and let someone over here talk to somebody over there. But of course, the constraint was we couldn't change the Ethernet packet in any way. We couldn't increase its length. There was not a single spare bit. And we couldn't change the way the end nodes worked. There were end nodes that thought they were speaking on a single link. So they had pretty much agreed that, well, you just kind of listen promiscuously and forward the Ethernet packets around, but there needed to be a spanning tree algorithm, which is spanning means reaches everybody and tree means no loops, because that wouldn't work if there was multiple ways to do that. So my manager suggested this problem on a Friday, and and he was going to be gone all the next week. I realized that night how to do it, and it was trivial, and it was like incredible. I could prove it worked and all that. I spent Monday and Tuesday writing the spec in enough detail that people got it working without even asking me a single question in just a couple months. And the remainder of the week, because I couldn't concentrate on anything else, I had to show off to my manager, and he was away, and this was before cell phones or email or electricity or whatever. So I spent the remainder of the week working on the poem that goes along with the algorithm, which was the abstract of the paper in which it was published.
There was some controversy at that time about whether this should or shouldn't be included in the bridge, because the hardware development team's default position was no extra stuff, period. And it's not a bad position for a hardware team to say, I want it to be as simple as possible, but no simpler. And so they said, we don't have it in repeaters, so we don't need it in bridges.
And that's another actually really interesting story, which was that I found out afterwards that the very first bridge that Digital sold was to the world's most sophisticated customer. And they were, I found out afterwards that they were saying, oh, we're doing all this complicated stuff. And the Digital salesperson was saying, it's just going to work. And they were saying, but we're doing this complicated stuff. So the world's most sophisticated networking customer had the world's simplest topology, which was two Ethernets and one bridge. And they plugged it together, and it didn't work, and they were like really upset. And when field service went to figure out what had happened, they realized this sophisticated customer had plugged both ends of the bridge into the same Ethernet cable. And so everything was working perfectly. The spanning tree algorithm said, hey, I don't need to forward. If I ever do, I will. You're right.
Yeah, a related disaster, and there are certainly many disasters along the way that got fixed, before the first bridge was sold, was we said, well, let's resolve this question about whether there should be a routing algorithm in the bridges. And so down in our lab in Hudson, Massachusetts, where corporate research had moved, we built one with a PDP-11 and a couple of Unibus adapters, and it was way bigger than that podium, and hooked it up on a Friday, went away, and then sometime over the weekend, somebody in there created a loop, plugged it in, and it brought down the entire Hudson facility. That's now an Intel semiconductor facility. At the time, they were running a distributed simulations for the development of the Microvax computer, using every computer in the building. And Bob Supnick's head exploded at that point, and it landed directly in front of me, and it was yelling at me. And so that got pulled off, and he said, you ought to just pull corporate research off of this network as well, besides this experimental thing. And that resolved for the hardware team whether or not there was going to be a routing algorithm in the bridges, definitively.
So, Radia, I just want to go back to just one thing that caught my attention, what you said. You said, so I went home that evening and the solution occurred to me. And then you kind of moved on. It's like, well, so then magic happened, and oh, by the way, so what happened? What was the insight?
Oh, I mean, it's after the fact, you look at it and it's just sort of obvious, how to do this incredibly simple thing. Should I quote the poem?
Please.
Okay, so the poem is called Algorithm, because every algorithm should have an algorithm, and it's, I think that I shall never see a graph more lovely than a tree whose crucial property is loop-free connectivity, a tree which must be sure to span so packets can reach every LAN. First, the route must be selected. By ID, it is elected. Least cost paths from route are traced. In the tree, these paths are placed. A mesh is made by folks like me, then bridges find a spanning tree.
And by the way, this will be the sobriety test after cocktail hour tonight. Anybody who cannot recite that completely will not be allowed to drive home. They'll set up cots here in the Computer History Museum. So Norm, you're off in Hawaii. You know,
Yes, I am.
tooling along, you're a professor, doing your research. At what point did you begin to suspect there was something weird going on in Silicon Valley?
Well, I got to Hawaii by spending 10 years in Silicon Valley. So I knew long before I got to Hawaii that there was something weird in Silicon Valley. I don't know when that struck Bob, but Bob was as he usually is, very gracious in crediting the work in ALOHA to what he brought to fruition in so many other places. And
So he had he was looking for that chapter in his thesis. He had contacted you, of course.
No, he had. He only contacted me when he finally got to Hawaii. And in fact, the whole process by which Bob got to Hawaii is one of these things that's sort of shrouded in the mysteries of networking. I don't know how it occurred. Bob says I invited him from time to time.
I thought it had something to do with the statute of limitations and jurisdiction, but...
It may have to do with the passage of time, but I don't think there's any statute involved. The first I knew is that Bob showed up as perhaps the only pre-doc, post-doc I've ever known. That is, Bob had not got his degree, I believe, when he got to Hawaii. He was still fighting with the people at Harvard. And the work that he did in Hawaii was helpful to us. Bob was involved with a lot of our graduate students, and Bob and I talked from time to time. But it was networking from the point of view of the ALOHA net. And perhaps one of the things that I should bring up is a question that was mentioned just peripherally in Bob's statement here. He's talked about the path from ALOHA to Ethernet. Of course, if you take a look around at all the computers that you see at the various desks here, everybody's connected not by Ethernet, but by Wi-Fi. And so there is a road from Ethernet to ALOHA that is interesting to me as well. And it seems to be the way in which things are going. With a great deal of pleasure, I noticed that the movement to the wireless end of what's going on in Ethernet seems a lot more robust and also a lot more lasting, I think, than the wired version of ALOHA, which Bob brought out. But I certainly see Bob as having invented both.
So instead of ALOHA being the Ethernet, that Ethernet is the ALOHA, and it's only appropriate that ALOHA means both hello and goodbye. So 40 years ago you said hello to the Ethernet. Now it's like, well, so long, it's ALOHA's future.
And we really haven't said goodbye to the Ethernet,
Yes.
but we have said hello to ALOHA again after a hiatus of perhaps 20 years. That hiatus, by the way, was not a technology hiatus, it was a regulatory hiatus until the frequencies were available for the connections that we all use today, there was no sense in going from Ethernet to Wi-Fi or ALOHA.
So Bill, you of course have been in the thick of all this, and one thing I should share is that we all have had this really wonderful email exchange before this panel, and I have got like 10 pages of really cool stories. Bill told some of the best, and I don't even know where to begin, but Bill, what was the part you thought that was most likely to fail in all of this?
Well, there was a whole list of things, but because it's much easier on the ladder of credibility to sort of fall off at any point than to actually get to the top in commercialization. For example, Jerry Salzer at MIT had written a paper, Why a Ring, which was all of the arguments for token rings. And this is back in the sort of early 1980 timeframe when we were building the 10 megabit Ethernet. And I put it on my cubicle. We were in the mill at DEC at the time with a dart, the kind you use in a bar. I just put it there and made sure you went down that list. And he said, a few things like they'll never get the random numbers generators to work. And so we said, oh, we can do that. And so we had a design, we got it, going and everything. And we built much to the annoyance of Intel at the time, because with the digital Intel Xerox, I think there was an implicit assumption that we were just going to use the Intel chip. So in order to fulfill that assumption, we designed our own chip and then licensed it to AMD and MOSTEC, figuring between the three of them, somebody would get it right, and that would drive the cost down and the bugs out and create a dynamic. The commercial terms on it were tremendous in terms of what we would have to pay. And so we designed that. We built 3 emulators of the chip and ran it, and we were trying to make sure everything really worked for commercialization. And over the weekend, all the systems drifted into sync. And so the collisions were backoffs. It was permanent. There were 0 packets going through the system. It would lock up. The closer the crystals were in frequency, the longer it would take to drift into sync, and the longer they would be in sync once the random number generators were synchronized. So this created a fire drill. Bernie Lecroute, who was running, he was sort of the division manager before he had left to go to Sun. We called him the Crusher. I'll tell you offline why.
No, I would just TTY interrupt. I think you need to explain Crusher.
Well, because a couple of us had gone and wanted a little bit more time, and because I had found some issues in the back-off algorithm in these simulations we were running, that this could be fixed and so forth, and so we just needed a little more time. And one person made the mistake of saying, Bernie, you can't get blood from a rock, and he says, no, but I can crush a rock, and he just crumbled up the paper and threw it. So he became called that Crusher. And so the things drifted into sync, and so we were all locked in a virtual room by Bernie and management to fix that problem. And the reason we wanted it fixed, and this relates to, I think, one of the very important commercial dynamics that was established with the 10 megabit, which was establishing a dynamic in the industry with semiconductors. And that's why we had all these implementations out, and we wanted to make sure the core piece was correct. So we built test dies at AMD. We came up with, there's not enough time to go into how it works, but we came up with a pretty elegant fix for that, and then we would channel that to semiconductors. One of the other companies in the collaboration didn't believe it was a problem because they built one emulator and it didn't drift into sync, and that remained a problem until many years.
So, first of all, if there are audience questions and comments, well, actually, would everybody in this room who had something to do with the evolution of Ethernet raise your hand?
Yes, that's true, right?
Come on, people haven't raised their hand that I know. That was the echoes of Token Ring. It's what happens when you do it in the ring. That's why trees are better.
This proves success has many fathers, but failure is an orphan. And I think Ethernet was particularly promiscuous in that regard.
Yeah, so question, just a follow-on question for you, Bill. Innovation, and Bob has written on this extensively, that we think of innovation, it's about technology, but of course it's about social processes, it's about interaction, and some of those can be quite colorful. We have a saying in the Valley many years ago that it's, for entrepreneurs, it's easier to ask for forgiveness and permission. Tell us about the time you got in a shouting match with Ken Olsen.
Well,
I mean, I know there was more than one, but...
when one person is doing the talking and the other person is trembling, it's hard to call it a shouting match. What transpired was, for some reason, the program manager thought it would be good for me to give us the status report to the executive committee at Digital, at DEC, at the time it was called DEC. And so he warned me that if Ken Olsen is humming or looking around, you're probably in trouble. And so I was giving this presentation on the status of what we were doing, and all of a sudden he was standing up at the end of the table, which seemed now to be as long as this room to me. It wasn't, but it sort of felt that way. And he says, "What does your badge say, son?" And I said, digital, and he says, does it say DEC or industry? I want to, and he said, why are you giving away my technology to the industry? And I thought this was interesting, and the simulations I had were called the DEC wire simulation. It wasn't called the Ethernet simulation. But nevertheless, we were trying to get it out into semiconductors and standardize so forth. The standards were just really getting going. That's a whole other topic in IEEE.
Well, Micro, I always thought that Ken's problem was he had a DEC wish, but
yeah. Well, so I said, well, I think the strategy is it's better to get a big piece of a small pie than a small piece of a little pie, or than all of a little pie. And so afterwards, I asked him, do you support this? Should I get on another project or something? He said, oh, no. I just wanted to see if you were going to be a leader or anything, because you need to have arrows in the back from your friends, in the front from your enemies. So it was great. Head games.
Oh, my gosh.
Oh, and just sort of a technical point. Other than the radio stuff, the Wi-Fi stuff, mostly Ethernet isn't CSMA CD anymore. It's just point-to-point links with, sort of a half-hearted layer 3 protocol, which is the spanning tree. But that was because, it wasn't designed to be doing that. But one of the other, one of the real innovations of Ethernet was the 6-byte address, which was a crazy idea because IP only had a 4-byte address and was intended to be the entire world. And Ethernet was designed for a few hundred nodes on a single wire. Why would they come up with 6 bytes? But, this notion that you wouldn't have to configure things, that it would get born with a unique ID that you could carry around with you wherever you are, was like a really cool idea.
Indeed. And, speaking of that, so about that radio thing, Dave, you really brought into this a radio aesthetic. As I recall, you're an extra class amateur radio operator, correct? Yeah. And so, to us on the outside, it looked like Ethernet was like, the idea was, oh, this is radio down coax. And I know that's a grotesque oversimplification, but how did your, radio perspective inform your design?
Well, it's not reliable. I mean, radio isn't, and you have to, somebody can always say, repeat please, something wiped it out, and so retransmissions and let's see, amateur radio people used to run message networks where they would accept written messages and send them by Morse code. And so I was quite familiar with checksums and retransmissions and all of that. So when Bob sort of said it to me, I said, oh, yeah, I understand all that.
Yeah, because it's fascinating to me that Bob came in, he discovered ALOHAnet, but I think of Bob's many accomplishments, he's not a radio geek.
Well, Paul, if you go all the way back to Bob's initially rejected thesis at Harvard, you'll find a description of the architecture of what he was thinking of in his PhD thesis. And Bob used the term, which I subsequently adopted in a couple of papers, was never widely adopted, but I thought was very insightful. He used the term packet broadcasting. And so it seemed to me that right from the beginning, Bob was thinking radio, but thinking radio on a wire. That is, he was broadcasting on the wire.
ALOHAnet. Bob talked about the ALOHAnet all the time. It was really the model that he was trying to just translate onto a wire.
Yeah, and he was grounded in radio, but he was constrained by the same thing that all of us were constrained about in those days, the FCC.
Yeah.
The FCC would not allow you to do this, and it took some it took some very inventive people within the structure of the FCC over the years to put us all on these little wireless units that we use today.
Yeah, fascinating. So we had a comment. The two thoughts I have as one is, the innovation process, this process of recombining things from other fields, really played out here. It was really a recombination of multiple perspectives. Also, the more I listen to this and the more I think about Bob's PhD getting rejected, I think I missed my opportunity. If I'd gotten expelled from Harvard in freshman year, maybe I would have had a real career, but who knows? Sir, tell us who you are.
I'm another Bob Emerson, freelance writer. Earlier, a few minutes ago, Radia, you said that we don't have CSMA, CSCD, I can't remember the acronym anymore. What happened to it? I mean, what allowed it to go away?
Right, well, it just, it turned out that it's kind of evolved to just having intelligent switches and point-to-point links, just like kind of layer 3 was, was going to do. I was actually on a panel once at a conference. I was innocently there, and somebody said, "Oh, I want you to be representing Ethernet versus token ring." And so I read up at first I said, "Oh, that's kind of hardware stuff, and I'd rather not." And they said, "Too bad. Everybody else has already said no, so you can't say no." So I thought I could do a really good job of advocating for Ethernet against token ring. And then I found out there was a third guy on the panel who was actually Sandy Frazier from Bell Labs, who I hadn't heard of at that point. And he was talking about star topologies, which didn't worry me. That was clearly stupid. It's a single point of failure. And then he talked first and just completely blew us away. So like with single point of failure, he said, look at this topology, looks like a single point of failure. But if look at Ethernet, where every component is a single point of failure, every transceiver, any one of them sort of misbehaving, the whole thing is down. And so I was thinking, is he just sort of really smart and he could have taken any position and, and blown us away? Or might he be right? So it turned out that he was kind of right, that the best way to kind of cheaply hook up a building was with, like a more intelligent hub and, hook everything together, and it's actually easier to isolate things. And then
basically all the things we argued against in the original thing, which is that picture that had the single wire and so forth, and the twisted pair and a single point in a wiring closet. Right. We were going to get rid of twisted pair and wiring closets. Whoops.
Right. And then, like if you couldn't have an intelligent thing with, 10,000 ports, you hook them into each other to get more ports, and then you need the spanning tree. And so, that's sort of how it evolved to be like a better way of doing things. But the packet format remains. So it's not clear when
Actually,
people
I
talk
have
about
it here.
Ethernet.
This is the last remaining thing from the digital Intel Xerox Blue Book. It's page 27. It's the packet format. It's right here. It's the final thing that's left.
And speaking of final,
just one comment about that, though, is it may sound pithy to say, well, we were going to get rid of twisted pair, and now we're on twisted pair and get rid of the Ethernet. The process and the core seeding, the core technology that seeded the industry, and then the standards environment, and a design which was just simple enough that pretty much anybody could get it to work, as opposed to you had to be a rocket scientist and everything had to be precisely the same, like a token ring, Christmas tree lights in series kind of deal. That allowed a industry dynamic where Ethernet could evolve in a sort of a just-in-time environment. So just when things sort of run out of steam, there's sort of a spring comes to the Ethernet and it reinvents itself, it gets reinvented. And that's the engine that's going on now. And there isn't any particular reason for it to stop.
and that's a perfect final thought. It's just the frustrating thing about today is I feel like we're just getting started on this panel, but of course we're out of time. So please join with me in giving our panelists a hand.